From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
We're going to see an inflection point in the additive industry towards the end of this decade. And I say that based upon my previous comment about hey, a decade ago, no one knew what additive was. Students didn't know what it was. Over this last decade, they all do, right? And most of them had some form of formal education around it. So if you kind of play that out, towards the end of this decade, those same students that now have formal education around it are going to not only be engineers, but starting to be leaders and kind of guiding the direction of where additive goes.
That was Anthony Mott. Anthony is a manufacturing leader at Wabtec. Currently, he and his team are deploying additive manufacturing solutions to the rail industry. Anthony is a Penn State grad, and throughout his AM career has spent time at RP+M as well as GE. Before we get started, head over to www.3degreescompany.com and subscribe to the podcast. Remember, you can listen to the show anywhere you download your podcast, including Spotify, Apple, Amazon, or Stitcher. Also, if you or your company are looking for materials, qualification, or general additive manufacturing support, reach out to the team through our website or via email at info@3degreescompany.com. All right, Anthony, thank you so much for joining the show today. Excited for the conversation. I think we'll have a lot to talk about in your kind of extensive career in additive. And so I like to start all of these conversations with kind of getting to know the person a little bit. So we start way at the beginning. Where'd you grow up? Kind of what were some of those early days that helped inspire you to kind of get on the path that you are today?
Sure. Thanks, Mike. Let me start by thanking you. Watched a lot of the 3 Degrees podcast over, I guess, the course of the past few years. We've been doing these, so I really appreciate the opportunity to come on and tell my story as well. So my story is nothing too crazy, I guess. Been pretty close to home most of my career. I grew up in Newcastle, Pennsylvania, a small town between Pittsburgh and Erie along the west coast of Pennsylvania. And I, in high school, good in the math and sciences, didn't really have a direction on where to go though. So my parents, fortunate for me, guided me into a career in engineering, and I landed in plastics engineering. So really didn't know much about it. My brother was at Penn State Barron, and I looked and I saw plastics engineering had 100% job placement, and I was like, sounds good. Let's give it a shot. And I can happily look back on that now and say, hey, it all worked out. There was a lot of opportunities along the way, people along the way that guided me to where I'm at now, though, that I'm very, very appreciative of. So Newcastle to Penn State Barron in Erie, Pennsylvania. I knew that there was more snow there, but I didn't really appreciate it until I got there. So it was a great campus, great college for me to attend, small enough where you had more of an intimate sense in the classroom, but still had a grade A education curriculum where I learned a lot, made a lot of great connections. When I was there, I did an internship. So I did an internship at plastics engineering, the processing, the design, the materials of traditional polymer manufacturing. And as you could probably start to see, that's kind of where the transition of kind of where I made my jump to additive took place. Internship doing in the injection molding space, right? And it was the summer of my sophomore year, I think. I often say I can thank a very hot Cleveland summer for my transition into additive, because they were asking for volunteers to do design work in the air-conditioned room, and just so happened they had 3D printers in there. So I often say that's my start. It was because of a very hot Cleveland summer and injection molding facility. So there in summer of my sophomore year, started doing this design work for parts to go on 3D printers that I knew nothing about. That place where I was doing these exercises ended up being my first company I worked for out of college, called Rapid Prototype and Manufacturing, RP+M, located in Avon Lake, which is west of Cleveland in Ohio. So that's the born, college, and then internship / first go into the career force. So
Awesome.
Yeah.
So you said you didn't have much of a context for what a plastics engineer did.
Yeah.
So how, like those first couple of weeks when you were on campus and kind of starting to take courses and talking to classmates, upperclassmen about the degree and kind of hearing what jobs they were taking, like what were your initial conceptions of what people did, and then how did that hit reality? Like as you started kind of getting into the work you were doing, what you were learning, and eventually your internships.
Yeah. I mean, whether it be first weeks or even last week's 4 years later, I still probably didn't have a full appreciation for truly what an engineer does day in and day out. So it was, I mean, I really highly encourage engineering students for the internships and more importantly co-ops because it valued my experience so much more. The engineering structure has been developed over many years, right? And it's wonderful in how much you learn, but there's such a big chasm between kind of those 4 or 6 or 8 years really into industry, and even with an internship, you don't really feel that. So to answer your question, um, I didn't really have a really good idea of what that looked like. I knew I enjoyed most of it. I liked interacting with people, so I thought application engineer I was told was, hey, that's a good avenue between the people and the engineering perspective. So I didn't really understand it. Again, like I said, even at the end of that 4 years, didn't have a strong understanding. So what I would say for current and future students, make sure you're talking to the people that are actually in the workforce, right? Uh, and I was fortunate that the staff, the faculty at Penn State Barron had strong industry experience. Sometimes that doesn't really happen where you make that connection. So coupling that is critical, and making sure the co-ops are really necessary in the development and even direction of an engineering student.
And so as you start your first job, what was the company's perception on 3D printing? They clearly had some in an air conditioned room. Like, why did they have them? Who bought them? Like in terms of
Yeah.
role, and like what were they doing there in the context of, you said it was injection molding, right? Was the primary business?
Correct. Yeah, family-owned business. Thogus is the name, and they're three generations, third generation owner, and they had about, I don't know, 30 to 40 different injection molding machines. The owner of the company, very future thinking, had invested in several additive machines. This was probably over at the 2009, 2010 time frame, so relatively early on into this huge wave that we can now look back on of additive. And so they invested in them initially to the form of, well, they have all these low rate initial runs of how do we deal with that? The injection molding space, we know of challenges kind of on those first 100 or so additive parts. So that was the initial kind of one reason. The other one was obviously lending itself more into the injection molding space was fixturing and also inserts, right? Uh, Kind of looking back, the injection molding was obviously had such a strong influence on the additive space at the beginning, and it's kind of disappeared. But it's now I feel like it's reappearing, and people are starting to reevaluate where it really makes sense at that conversion point between additive and injection molding. So it's starting to kind of reinvigorate itself really in that space. But that's why it was invested in, which is now 13 some years ago, in that company.
And so, talk about kind of your first couple years in the workforce. Like, what were you learning? What were you doing? Kind of, did your perception of what you were interested in change at all?
Yeah. So I at the time, even whenever I started it and I kind of glazed over it, I additive what I could tell was for me. The injection molding space, while it was very interesting, it was a rule book, right? I learned in my 4 year education, I learned all the rules, and now I had to go out and apply it. In this additive space, there wasn't any rules, right? Like everyone was making it up on the fly. There was no how-to on to operate within the additive manufacturing ecosystem space, and even the machines themselves, you had to figure it out, right? So it just catered to kind of like what I was looking for in a career more. figuring things out, opposed to applying this tribal knowledge into what I was doing in the day to day. So that was the first thing that, even coming from my internship in, I knew that it was an attractive space because it was uncharted territory. My roles over that time, I would say over the first 3 years at the company, I was the design engineer, and I was a research engineer, right? So I was behind the desk and on the machines, which was awesome. Like, my whole approach to my career has been to get different perspectives, understand kind of the full range of kind of like, as you go through an engineering part, who all touches it, right? So I've now been fortunate to sit in a lot of those seats that operate, right? So at the time, starting from the bottom of the totem pole, I was designing parts, understanding kind of like what actually is going into this, right? What are all the intricacies that I need to think about as a design engineer that impacts additive? Then, as again on the behind the machine as well, I was able to get my hands dirty. So I was able to learn firsthand the challenges, the opportunities of what these additive machines bring, and came to appreciate and be able to handle more problems than from different seats from the beginning.
What kind of machines were you running?
Sure. Yeah. So for a startup, it was really impressive. We had several Stratasys machines, both on the smaller scale, like the Dimension, the whole way up to 900s and a few in between. But then we also had an EOS M280 and a binder jet, an M-Flex. So one of the first M-Flexes that were in the wild, really. So again, we ranged in size from maybe 8 or 10 people from the start to about up to 20, and it kind of fluxed in between. But for a startup company, having 3 different technologies, it was awesome for a junior engineer at the time to get a really wide view on, especially 10 years ago, a wide view on what additive is and the different ways you could apply it within the world.
And I imagine too, part of your job, especially at that time, even today, is um, coming to the customer where they're at in terms of understanding what the machine can and can't do, right? And so, like, you can only design so much to get fit into an M290 or 280, whatever it was, and same on the FDM side. So, what were some of those kind of early discussions like? Have you seen like the customer intelligence or understanding the technology improve since those 10 years ago?
Oh, for sure. Yeah, I'll say I'll go to the customer perspective in a second first, but kind of just the first to show the difference in awareness, we'll say, of additive. I'm big on outreach and education, so I would speak to elementary, middle, high school, college students back at that time, and I still do it to a degree right now. At probably 2011, you would ask a student, do you know anything about 3D printing? And there might be one hand that went up, right? There would be one kid in the class that heard about it. Now, I mean, no matter which level of education, elementary to college, everyone not only has heard about it, but most likely has had some involvement in their classroom with it. So over the stretch of 10 years, that's enormous to change education, right? Now, I know there's definitely still a long ways to go around the awareness of it, but that definitely speaks volumes to kind of the change in just knowledge base. Even myself, I spent 4 years and I had 3 days of additive in my engineering degree, right? So that alone tells you kind of, that was a decade or almost less ago now. To your point about like the customer awareness, it's definitely come a long way. I still, like, we'll say other week, have conversations of people asking for bolts and brackets opposed to an engineered product. So still a ways to go, but definitely people are much more aware. Customers are aware of limitations, opportunities of the technology and what it can do.
And what was it like? I mean, were you doing a lot of metal work as well? I mean, you came out of school mostly plastic focus, early internships, kind of plastic stuff. You have the DMLS system on the metal side. Like, what was that an interesting technology to you? Kind of what was your perception, kind of applying some of the fundamentals on the polymer and material science side over the metals?
Yeah, most of my work, 80-90%, was on the polymer side. Again, a decade plus now ago, the metals machine was a bit of a black box on like input versus output. A lot of learning that happened over that time. But it wasn't as repeatable, as robust as they are now, fortunately. So I again leveraged kind of my knowledge base on the injection molding. Material science doesn't change, additive or traditional. So I was able to leverage that and bring it to the FDM side, where again I operated into a few different seats. So at the startup environment provided such a great entryway into the engineering space, where got to, like I mentioned, design parts, work on machines, talk to customers. Wouldn't have got that in a lot of other places. But on the metal side, I did a little bit of project managing. Really was the only thing I did on the metal side. I didn't get the really strong exposure experience until I made my next jump into GE. Whenever I went to the Pittsburgh facility, the CATA facility in 2016. So that's whenever I got my, it was a whirlwind of knowledge that I was able to start to gather. And then eventually I got my master's in additive at Penn State, and that further deepened the metals knowledge for me.
Cool. I mean, since you mentioned it, let's go a little bit deeper on the GE transition.
Yeah.
How'd that work? What it was CATA, or what is CATA, I suppose, and what what was your initial role, kind of vision for the facility there?
Yeah. Yeah. Kind of connecting the two, RP+M to GE. So one of my former colleagues you had on here, Ed Herderick. So Ed was a colleague at RP+M, and then Ed was a colleague at GE as well. And again, speaking to the RP+M, there was, for a small company, we had a variety of technologies. There's so many people that are still in really great spots within the additive industry and still really active. So for a startup, it was awesome. Such the amount of talent that we had there was great. So to highlight on the transition, I went to the Pittsburgh facility. I wanted just to get a different exposure. Startup company, I went pretty much as far the other end of the spectrum as you can from a startup to GE and a giant conglomerate, right? So I went there as a project manager. CATA was the center of additive technology advancement for GE. Was targeted as the flagship of how does GE just accelerate additive across all the businesses. So while our customer were GE engineers, it provided us into 8 different industries, experience of kind of my visibility to 8 different industries. All the businesses came to our Pittsburgh facility, and whether they had a very clear mission and direction like GE Aviation, or maybe they're still figuring out like some of the other GE businesses, the smaller ones that they really haven't found their part, like the fuel nozzle, right? So not only provided different engineers with like different levels of awareness, education around additive, but also like different direction on what's important to them. Is a metal part more important than a polymer? And kind of like, what are their product line, and how does that influence how you need to use the technology? So it was again another a really great opportunity to, and it was a startup really. So even though it was GE, there was 4 walls, a bunch of machines, and no processes. So it provided me more operational opportunity of how do you start to stabilize this and stop making it like an R&D tool and more like a real production tool. So that was the start of kind of like, how do you start putting boxes around this technology so you can get a quality part and experience for your customer at the end of it.
And what did you like and what did you dislike about the bigger company structure versus the startup that you had been at?
Yeah, the first few years, it honestly didn't feel too different. We were the new exciting toy within GE. There was a lot of people who wanted to interact with us. Processes were still being developed, so there's a lot of flexibility. So there weren't too many things that I disliked at the start of it. So I would say ultimately though, there's a little more hierarchy and restriction as with any larger company, and for good or bad reason, right? So that would be the only obvious difference between the startup and the GE environment, as started to experience years into the development of CATA. So a little more ribbon around actually getting things done, but it is still a great environment. Again, able to get visibility to the 8 different industries and talk with tons of really talented engineers across the company was extremely valuable lesson for me.
And then you said this is kind of where more of the metals stuff started to kind of bubble up
Yeah,
to your experience. Was
sure, sure.
that in conjunction with doing your master's, or kind of doing everything at the kind of the same time here?
It was definitely, I would say the majority of it was the first 2 years. So
Okay.
2016 to 2018. Uh, on the ground floor, we had this was prior to the Concept Laser and RCAM acquisition. So we had EOS machines, we had SLM machines, we had Concept machines, we had RCAM X1, variety of polymer printers as well. So it just continued. I had a good exposure to the kind of three technologies, and it was just magnified. It got bigger at the GE site, right? So really strong, really diverse investment around all these tools. And as the project manager, I had to interact with engineers internally who were actually operating the machine, and externally our customers. How do we deliver a good part? So I had to quickly learn asking all the right questions to make sure that we can get there, asking the customer questions on quality and understanding their application, as well as internally, and actually understanding the metals machines that I didn't really have a strong foothold on. So that was the most valuable knowledge around metals for sure. Come 2018, it reinforced my knowledge whenever I started my master's program at Penn State. I think Penn State was amazing that they were kind of the first ones to the really in the academic race to get a real master's degree for additive. I know that several others have followed on. There's still tons of certificate programs out there, but um, it deepened my, I would say, the material science knowledge around the metallics space more than anything. The processing side and the how-to additive, there's no experience like doing it firsthand. So those first few years of GE were really valuable for that.
And did you completely stop working and do your master's, or were you doing it kind of part time alongside your job?
Yeah, the master's program was done in conjunction with working, so it was part time over 2 years or so. Um, yeah, so I was able to do both at the same time.
What was your schedule like doing that? Were you like 9 to 5 and then doing a class a night or something like
Yeah,
that?
it wasn't too bad. So the master's program, you could do it in a 2 year basis, part time, doing one or two classes. So I finished school around 2013, 2014. Took, I would say, so about 4 years off. So I had to rethink about like being on an academic calendar versus on a work calendar. So you had to be a little more flexible. But yeah, pretty much in the day I was doing the real actual work on the machines and stuff, and then at nighttime or fitting it in between meetings, I was able to do some academic work too.
And I suppose that's such an advantage to most people taking that class, right? Like you have essentially infinite access to any of the technology out there, probably even more than some of the professors teaching the classes, right?
Oh, for sure, yeah. I mean the lab that we had at CATA, GE CATA at the time, was extremely impressive, right? There's not too many places in the world that have that number of machines and variety of technologies all within four walls. And not only that, we had the post-processing equipment as well to support it. So it was again, like looking back 8 years ago or so, it was extremely innovative to pull most of the supply chain into one building and being able to finish a part all within the same space. So I'm still I'm extremely very value extremely my time there because of all of the cool equipment, cool projects that we had to deal with, and most importantly, learned from an amazing group of engineers over my time at RP+M and to GE as well.
And then as you were thinking about doing your master's and ultimately doing it, completing it, kind of what did you have in mind in terms of the end goal? What did you think it would help you do further on? I mean, increase your knowledge base, but kind of what would the implications of that be for how you were thinking about your AM career?
Yeah, at the time and still now, I know education is one of, if not the biggest hurdle within additive. So no matter how you look at it, I believe education is the common factor to continue growing what we're all trying to do in this industry. So I knew, so having that idea combined with, I was always extremely involved in as I mentioned, education of grade school, high school, college, connecting what I do to students. So I knew it would be good to have just like a consolidated source of like all this stuff that I've been doing, right, except in education format. So what I wanted to do out of it, like you mentioned, was to deepen my knowledge around more of the metallics. I already had an engineering uh, understanding of the polymer bases, material science mainly. I needed that. I needed to couple that in the metal side for me personally, but more importantly, how do you instruct additive? What is the proper way on how to consolidate all the knowledge that we have and to deploy that to engineers in my case? How do I educate better? So I was looking for the master's program to help really parse ideas and then deploy that knowledge base to others.
Did you think at the time that metals was going to kind of overtake polymers? Like, I mean, certainly in GE's investment, right? It's going to be more expensive to implement the metal side because the machines, the price of the materials, the post-processing, all that versus polymers. But like, did that have any factor? Like, would you say like, oh, like you can do more real stuff on the metals, or like it seems like you're kind of the ebb and flow of additive is every 3 years it switches, like polymers is the cool thing and metals is a cool thing, and it's kind of going back and forth, right?
Yeah, I don't know if it was, I mean, I probably felt that at a time. Again, I was metals were the thing, and GE, and even now in my current role here, there's much more impact. And that's based on my product line, which we'll get to kind of my current role in company. But metals, the polymer side, to know that there's not just one tool, right? There's not just one material. This is a very complex ecosystem in additive, and there's going to be many things that move the needle, move the additive space forward.
Yep. So, I mean, you hinted at it a little bit, kind of, you're not currently at GE, you didn't stay there forever. What was next on your career path, and where was that decision point?
Sure. Yeah. So 2016 to 2021, I was with GE. So and I had a variety of roles there as well. Project manager. I was able to kind of interact with customers. Additive engineer. I went back to behind the machine, being kind of leading a cell and a small group of people, and then I finished out as an operations manager. So seeing more of the site and understanding kind of the intricacies of like how all the processes interact with each other, how parts flow through the process. So starting to kind of like increase the view of kind of the overall flow of the facility. So 2021, I transitioned to Wabtec. So Wabtec, uh, part of Wabtec is former GE Transportation. So Wabtec is pretty much three unique companies that we saw integrate over the past 5 years. That is Legacy Wabtec, which is Westinghouse Air and Brake Technology, GE Transportation, and a transit company called Favorly. So now we are Wabtec. It's a rail company. The highest level, kind of the divisions are freight, locomotive, and then transit components. So people movers, right? So again, I had some exposure to that whenever I was at GE, seeing the GE Transportation products. And funny enough, of all the GE businesses, I looked at that and I was like, I don't know if I could ever operate. Like of all the, like we had really amazing looking into it. I didn't really recognize it, but now there's amazing engineering that goes into every product that we make, and even something that may seem as simple as a freight locomotive. Um, there's so many man hours and knowledge base that has gone into that, and I've gained such an appreciation of the product that we have across all of our rail products. And so now to get to it, I'm the global additive leader for Wabtec. So what my mission is to integrate additive across the company. Obviously, a great infusion from GE Transportation, that initial knowledge from 2016 on. And again, Wabtec is now, it's a 27,000 person company, global company. There's so many different pockets of the business that I get the opportunity to educate and to print parts and to make product for now in my current seat.
And with that kind of vision of kind of global head of additive for the company, is it kind of coming in? Did you have like specific areas where you want to hit, like we need to make this stuff lighter, or we can't find this material anymore, or this part has been made by some guy in a garage injection molding and we need to replace it? Like what are some of the problems that you're looking to solve using additive? I mean, you can be general or if there's specific cases, but like who care, like rail, like I mean we've been doing rail for 100 years, right? So like what is the benefit of additive, and why are you thinking about this technology, kind of given some of the limitations in price and cost?
Yeah. So I generalize kind of the two different divisions into freight and transit, right? But there's so many different pockets of the business where it depends, and just like any industry, it really depends on like why use additive based upon what the application is doing. So always starting off with application, then going from there. The applications are what drives every decision. But on the transit side, actually, you just mentioned that we've been doing rail for hundreds of years. One of the most exciting products that we have, and we've showcased it, did public case studies, is the brake panel, pneumatic brake panel. It's a manifold, and again, Westinghouse air and brake technology. So the namesake of our company is around air brakes, and we've been making this brake panel the same way for about 100 years or so. The same way that George Westinghouse was doing it way back when. You get several aluminum panels, you mill it out, you put gaskets on it. Really laborious type of process, high quality fallout, and instead of having these huge chunks of aluminum to get air and to deploy it to different areas of your vehicle, we're not printing it, right? So why use additive? I mean, it's checking all the boxes. You're lightweighting, you're improving performance, you are going to reduce quality fallout, you're consolidating parts. I'm super excited about this product and product family. There's so many of them with Wabtec. It's again, air manifold. On transit vehicles, there's air that's operating pretty much everything on the vehicle, right? So we're just starting to scratch the surface with these brake panels that we're doing, and you could look up Wabtec brake panel, and there's several of them that might hit. But yeah, so that's one example, right? On the freight locomotive side, completely different criteria. If I go into an engineer's office and say I can lightweight something, they'll laugh at you because they don't want to lightweight anything. They actually want to increase the weight of things. The freight locomotive is the thing in front of the train that's carrying 1 million pounds plus. So they need really heavy locomotive to pull the load, right? So I don't want to lightweight it. In fact, they weld plates onto some of the parts in the locomotives to make it heavier. So whenever we always pull the back pocket of I can make it lighter, doesn't work in this case. The areas that I'm really attacking, or my team's really attacking, are around improved fuel efficiency. What's our customers value is fuel. I mean, that's the number one, number two cost to them. So that's important to us. So there's obviously lots of opportunity you could find. What additive has done for improved fuel efficiency, we have several efforts around that, and just anything around the engine. How do I improve the engine performance? So digging into all of our tools that we have within additive in this full ecosystem to see how we can improve our freight locomotive engines.
And has the approach been to kind of see kind of what applications kind of rise to the top and have kind of internal ability to produce or manufacture this, or are you looking to partner with other organizations to produce and manufacture? What's kind of the balance that you guys have thought out about that?
Yeah, you just the manufacturing side, you mean?
Yeah. Like once you have an idea, right? Or once you have a concept, like, hey, this is going to work. Like, are we going to do it internally, or do you guys outsource that sort of type of work?
Yeah, we're extremely invested into the space, and so we are going to manufacture everything, obviously within the confines that we have, the machines that we have. We have 5 labs across the world right now. Those labs, 3 of them are in Western Pennsylvania. We have one in Bangalore, India, and one that we just opened up in Tours, France, which is just around Paris. So a variety of machines, tools. Again, for an industrial component maker like a Wabtec, it's tough to compare ourselves against other rail providers because not many are at the stage we're at in this additive journey. But just looking at industrial components, we're extremely diverse in the equipment materials that we've invested in, and we recognize the barrier of cost that it always happens. So we've invested in the technology to bring down that initial cost for our customers to try to increase the amount of potential parts that we can produce. So unless it's something extremely unique, we would be the manufacturers for it.
That's awesome. And now, as you have kind of seen the technology over a decade and seen kind of your roles change within it, what are like one or two learnings that you've kind of taken away from all that experience? I mean, you've got the masters, you've got the hands-on experience with the machines, you've seen global companies, you've seen startups. Like, are there threads that you're excited about, or things that you're kind of the key takeaways that you've seen over the last few years?
Sure. No matter, I mentioned the first one is around education. I think we're going to see an inflection point in the additive industry towards the end of this decade. And I say that based upon my previous comment about, like, hey, a decade ago, no one knew what additive was. Students didn't know what it was. Over this last decade, they all do, right? And most of them had some form of formal education around it. So if you kind of play that out towards the end of this decade, those same students that now have formal education around it are going to not only be engineers, but starting to be leaders and kind of guiding the direction of where additive goes. So we're all continuing to push forward, not waiting for just this new influx of engineers to happen. But I really think at that time, many engineers are going to think different about how to apply additive, and not just throw something over the wall, but think, what is the technology? Why am I using it? Right? We're all excited for additive just to be another tool in the toolbox, as many of us say, opposed to this special thing of where we're chasing headlines. So end of this decade, I think education is going to actually be a really impactful thing, and kind of we'll see a change there. The other comment I'll say is, no matter the challenge, I think we could point back to the machines as being the common thread, right? No matter how we're applying additive, the machine is doing the work. And we've come so far in the repeatability, the robustness of this equipment over the decade. But there's still so much farther it needs to go for us to be truly an industrial, for additive to be industrial technology to produce parts on the same quality scale of a machining or casting, or you name the technology. So machines need to improve is the biggest thing for us to continue growing, for it to be more repeatable than it is right now, and continuing to double down on education to make sure that we're educating the engineers in the proper way. We're not chasing headlines to say additive can be things that it's not, and using it for what the technology was designed for.
Cool. I just got two more questions. One question is one of my funnier ones. I like to kind of, for people who are new to the industry or even new to work, I mean, what does run through a typical day for us? Like, what do you get up? What are you doing? What's the schedule like? You've got these facilities all around the world. Are you up at midnight or 4 a.m. doing calls with France, and then you go to India late at night? What's a typical day go?
Yeah, it's definitely there's some early mornings, but we're fortunate within Wabtec, and I generally think within the U.S., really, depending upon the makeup of the company. So I have 2 little ones, so that kind of sets like a part of the day where I'm getting them off to school and everything. So depending upon meetings, I'm either up. I either have 1 or 2 meetings from like 6:30 to 7:30, and then girls to school, and then from there, I'm trying to do better about meetings. Like, it's tough to not do them, because again, I'm in a global seat, so it's a very necessary thing. But especially even whenever I go to the labs in Grove City and Erie, and then our other lab here at Neighborhood 91 in Pittsburgh, which is closest to me, I'm often in meetings most of the day. So my day looks like lots of meetings generally, interacting with my team, interacting with engineers across the company, to again just evangelize, advocate for the good word that is additive, and telling people about what we can do and kind of walking through projects and the execution piece as well. So every day looks different, though. I would say the common themes are some early mornings, not too often, but then tons of meetings throughout the day to just navigate the world that we're living in right now.
Cool. All right, and last question. We started this late last year. What's a book that has made an impact on you, or how you do business, or how you think about life in general, that you've read recently?
Yeah. Yeah, so actually I saw your post that you made, I think at the end of last year. I can't remember when it was exactly, but the book that is Extreme Ownership by Jocko Willink. So
Nice.
former Navy SEAL, absolutely love it. I read the book in early 2021, and this was actually at the rate I was looking for other roles at the time, and I included in several aspects of like his thoughts and kind of the main takeaways of the book, and I included that throughout my interview process, and I still use them honestly, if not daily, weekly, and just reminding myself of some of the things. Right. I think as engineers, it's a really tough job because like in our world, all the leaders are mostly engineers. Not many have had any formal education around leadership. Many of what we learn and deploy in kind of our leadership tactics are our own managers and leaders that we've had, and then maybe a few books or things you read, right? So for me, leadership is it's a topic that I'm fascinated by, and it's a common theme no matter which industry you're in or no matter what your goals are on paper throughout the year. Leadership's a common thing. If you improve that, you can improve every one of your goals, right? So it's such a valuable topic, but we don't really focus on it as much.
Awesome.
To get back to the book, though, there's so many different themes of what kind of Jocko wrote about that I've been able to introduce in my day to day, week to week, and I think it's just the way he formulates things. It's very conducive to how engineers' brains operate, and he lays it out very logically, methodically, and it's done myself some good to think about those things.
Nice. And I don't know if I mentioned this in the post, but I got to Jacko's got a consulting firm called an Echelon Front.
Yeah.
And so I did they put on these leadership kind of 2-day boot camps where you go out to a paintball field and you kind of learn the principles of extreme ownership and the 4 laws of combat and things like that, and real life kind of scenarios. So there's 30 people, you don't know any of them, and they kind of go put you out into these scenarios and you do debrief. So it's these principles do work. I'm a huge fan, and so
that's amazing. No, I'd
yeah.
love to hear more about that. Wabtec, we had Echelon Front come in, and I can't remember the pilot. I can't remember the gentleman's name at Echelon Front,
Okay.
but he came and he spoke. He went to Erie. The Veterans Forum brought him in, and he spoke about extreme ownership and kind of again different aspects from the book to engineers, and it was extremely well received, and the content's awesome there, I think. So it's cool.
Awesome. Well, I appreciate the time today. Thank you so much for sharing your story, and we look forward to seeing all the new innovative products that you guys are coming up with.
Mike, I appreciate it. Thanks again.